Okay, so again, 9-3, we're going to transform piecewise defined functions. This is the first time we're really going to look at the rule for a transformation. And what a rule for a transformation looks like, this part you may, or this is kind of review, you don't really have to write this part down. You can if you want to. But the rule for a transformation, they're going to write something like, G of x is going to be equal to f of x minus 2. So let me take you back and kind of review section 8-7 with us. 8-7, that was when we were transforming like the square root graph and the cube root graph. So I'm going to use that, all right? The functions that we're going to use today are not necessarily the square root or the cube root, but it's the same idea applies. So I want to go to something that you've just done recently so that it will look more familiar. So let's say back in section 8-7, you guys had a function that was like f of x equals the square root of x. Okay, and then you guys remember that was one of your basic graphs. That one basically looked like this, right? All right, well then what they would do is they would define a new function right here that would be g of x, and it would be f of x minus 2. So do you see how that x minus 2 is in parentheses? That's kind of like your input into your function. So what you would do is, in this case, using the function f that we have written over here, the f of x equals the square root of x, what g of x would look like then is it would be g of x, that function g would be the square root of the quantity x minus 2. Okay, so that x minus 2 in parentheses, that's kind of like your input, okay? That's what you plug in. So you're going to take x minus 2. If it's in parentheses like that, you're going to take that and you're going to put it in right there for x. Well then, now that should look familiar to you guys, right? So this is just like a new way of writing the rule for a function, all right? It's just function notation. So do you guys remember, what is this transformation right here? If I subtract 2 from x inside there, what's the transformation? Which way? Good, yeah, it's right 2. So your book would say that's a horizontal translation, right 2 units. So we'll just write right 2. Okay, and then maybe they define another function for you here. Maybe they'll do h of x, and they'll say that that one is f of x minus 2, like that. Well, now this function here, f of x, this is the whole function f, okay? And again, over here on the side, we had that f of x was equal to the square root of x, right? So what we can do then is we can take that whole thing, the function f, and we can plug it in right there for f of x. All right? So then we're going to get a function that's going to look like h of x equals the square root of x minus 2, like that. So again, that should look more familiar again. So then what would that transformation be right here? If it's the square root of x minus 2 on the outside. You guys remember?
Down 2?
Yep, that one's down 2, good. So that one would be down 2. So that would be your transformation, down 2. Now your book would say that's a vertical translation, down 2 units. All right? So that's kind of how, I'm just trying to get you used to this function notation, okay? That's the rule for the function. Now what we have to do now, though, is we're going to apply those ideas to piecewise defined functions, which is what we were working on late last week. So let me write one of these functions for you, and then we're going to work our way. We're going to do 8 different transformations, okay? Not all at once, but 8 separate transformations on a piecewise defined function. So let me go to the next page. Oh, apparently, well, maybe it will. Yeah, it will, okay. All right, so here's the function. So the function I'm giving you guys, this is going to be, we're going to use this function over and over again for all 8 examples. So we've got a function here. Let's see, I got to zoom this way a little bit, maybe. Hold on 1 second, guys. I could probably just do this. Let me see if I can get... Can I just zoom in more or no? Yeah, that'll work. Okay, so here's our function. So the function we're given is f of x is equal to, it's got two branches or two pieces. So the first branch is 2x minus 3, and that's if x is greater than or equal to 1. And the second branch is just negative x, and that's where the x's are less than 1. So 1 is our, x equals 1 is like our boundary between our two functions. So it's one graph, it's one line graph to the left of x equals 1, and then it's a different line graph to the right of x equals 1. But those are our two pieces. And then what we want to do then is we want to transform this thing. So we're going to make a new function now. So this new function is going to be g of x, and it's going to be f of x minus 2, just like I did on those on that previous example for you guys. All right, well, this is different because we're going to transform a piecewise defined function. But again, if it's in the parentheses, it's like it's inside, okay? So if it's in the parentheses, what you have to do on this one, and maybe I'll draw all this and then I'll just erase it out. You have to take x minus 2, and you have to plug it in for that x right there, and for that x right there, and for this x, and for that x. So everywhere you see, if it's in parentheses, everywhere you see x, you're going to replace it with x minus 2. Okay? And that's going to be for all the horizontal transformations. You always have to plug. So I guess what I'm trying to say is on the horizontal transformations, you also must plug the quantity x minus 2 into the x's that are in the domain of each branch. Okay, if it's going to be a vertical transformation, then these are not going to change, and we're not going to plug into the x's for the domain of each piece. Okay, let me get rid of all these red lines off here, though. Okay, so here we go. So this is going to look like this now. So we've got, this is going to be equal to, so we've got 2 times x minus 2 minus 3. And then we're also going to plug it into the domain, so it's going to say x minus 2 is greater than or equal to 1. And then we're going to replace the x in the bottom piece with the quantity x minus 2. And then that's going to be where x minus 2 is less than 1. Is everybody okay? Does everybody see what I did? I just replaced all the x's with the quantity x minus 2. And then you just simplify that and you're done. All right? So if we can simplify that, I don't know if I can't zoom in any smaller. So what we're going to get here, I'll just simplify it down here. So we're going to get, well, obviously we're going to have to distribute right here, okay? We're going to distribute the 2. Down here, we're going to distribute this negative onto both terms also. And then over here on where the two domains are, you still have to solve that for x. So on the domain of the top piece, we're going to add 2 on both sides. And then same thing on the domain on the bottom piece, we're going to add 2 on both sides. So that's all the work. Huh. It seemed like that was pretty quick. So we're going to add 2 on both sides there on the inequality for the domain of the bottom piece also. And then we just simplify that and we got it. So let's see, the top one up there, we got 2 times x, that's 2x. Then we'd have 2 times negative 2 would be a negative 4, but then also minus 3 more, right? Thank you. So that would look like, that would be 2x. Let's see, we'd have a negative 4 minus 3 more would be minus 7. And if we solve that inequality on the right there, that would become x is greater than or equal to 3. And then the bottom branch, we're going to distribute that negative, so that gives us negative x plus 2. And that would be where, oh, I forgot the equal to bar there. That would be where x is less than 3. Okay? And again, we do want to make a note here. I forgot to make it. What transformation is that again when we subtract 2 from the x?
Right 2?
Yeah. So it's right 2. And at some point, maybe for the people at home, I won't be able to do it, but maybe I'll graph one of these on the calculator when we're done. And if they have any of those apps that I said you could download at home, what you could do then is you could graph this original function f on your graphing utility. And then you could graph our answer right here. And what you should see is that this graph just got moved to the right 2. So like I said, maybe when we're all done, we'll graph one of those anyway and take a look at it. Well, let's do the next one. So the next one now, if you guys, does everybody got that? Because I'm going to erase here so I don't have to rewrite that original function over and over and over again, all right? Everybody good? Okay. So I'm going to erase this stuff. So we're going to keep that original function still. Actually, maybe I will rewrite it one more time just because I want to make it a little bit smaller. I want to have a little bit more room. So let me go to a 12th page here. So I'm going to rewrite the function one more time, and then I'll start erasing. So let's see. So the original function was can I get that smaller or no? I don't know. Maybe I should do that. That looks good. Okay, so here we go. So the original function, same one we had before. So it's f of x equals, it's 2x minus 3, where, or if the x's are greater than or equal to 1, and then it's negative x if x is less than 1. Okay? So now the function we're going to do this time, I'll just call it g again. So this function is going to be g of x, and kind of like the second example I did when I was introducing this notation, this one is going to be f of x minus 2. All right, do you guys remember what kind of transformation that was? If I take the whole function minus 2, what was that second? I was going over 2 examples there in the beginning. Which kind of transformation was that to subtract 2? Again, it's not subtracting 2 from x, it's subtracting 2 from the entire function. So which way does it shift?
Down 2?
Yeah, thank you. Thanks, Cal. It's down 2. So this is down 2 units, okay? Well, when it's a vertical transformation, then these are not going to change, okay? Those are going to stay the same, those 2 domains. Because if you figure, if you just move this graph down 2 units, it's still going to be the one graph to the left of x equals 1, and it's going to be the other graph to the right of x equals 1. So the domains do not change on this one when it's a vertical transformation. So then all we got to do is subtract 2. So all we're going to end up doing is we're just going to end up subtracting 2. Let's see if I can draw up here, and then I'll take it out of there. We're just going to end up subtracting 2 from this top branch, and we're going to end up subtracting 2 from that bottom branch. That's all we're going to end up doing. All right? So let me take that out of there, though, because it'll make a mess, all right? But that's all we're going to do. So undo that. So then our function is going to look like this. So it's going to be 2x minus 3 minus 2. I said that domain is going to stay the same. And then this one's going to be negative x minus 2. And again, that lower domain is going to stay the same. Then we just simplify that, we're done. So the final answer for this one is 2x, well, we got minus 3 minus 2 more, so that'd be 2x minus 5, where x is greater than or equal to 1. And then we got negative of x minus 2, where x is less than 1. That's all. So once you kind of get the idea, it won't be that bad. But again, what we would see if we graph this on a graphing calculator, if we graph this one right here, our original function, and then we graph this final one right here, what we'd see is that graph just got moved down 2 units. Okay? Every point on the graph would get moved down 2 units. Has everybody got that one then? Because now I am going to erase. Everybody good? Okay, so that's 2 of them, so we got 6 more to go. All right, now the part I'm going to erase is I'm going to erase all this stuff. We're going to keep our function up at the top because we're just going to keep transforming that same function. Okay, so the next one we're going to do g of x equals f. It equals f of negative x. Now, can you guys remember what the transformation is for that? So this transformation right here, that's where the negative is on the x. It's not out in front of the function, it's inside. Anybody remember? Well, in the meantime, I'll draw this while you think about it. So what we're going to do, again, if it's inside the parentheses, if that negative, like before, it was the minus, the 2 was subtracted from the x in the parentheses on the first example of this part. But this one, the negative, again, is on the x, and it's in the parentheses, so it's inside. So it's like you're putting a negative x inside, or like the input into the function is negative x. Well, that means you're going to have to take that negative x, and you're going to have to put it in for that x, and for that x, and for that x, and for that x. Okay, I'm not going to leave all that on there, but that's what you got to do. Because this is a horizontal transformation again. So did anybody come up with what it is?
Y-axis reflection.
Good, yeah. Thank you. This is a y-axis reflection. Maybe this one will be the one we graph on. I did show you how to graph these on the calculator last week, didn't I? I believe I did, right? You guys were here for that. So maybe we'll graph this one on the graphing calculator and take a look at it then. Okay, so let's replace all those x's with negative x's. So our function is going to look 2 times negative x minus 3. And then we've got to plug in a negative x into that domain. And then we're going to have the negative of negative x. And then we're going to plug negative x into that domain also. So it looks like that. All right, well, then we got to simplify this thing. All right, so let's see. At the top branch there, we've got a 2 times a negative x. So that is going to be just negative 2x minus 3. And then the bottom branch, or the bottom piece, we got negative of negative x. Well, that's positive x. And then we just got to solve for x in these domains. Well, how you solve for x in those domains is you would have to divide both sides by negative 1. Because you want it to be just x. You don't want negative x. Well, if you divide the left side by negative 1, then you just get x. And if you divide the right side by negative 1, you get negative 1. But you got to remember on an inequality like that, if you divide both sides by a negative, you got to flip the inequality the other direction. So this should become, instead of a greater than or equal to, it should become a less than or equal to. Same thing on this one. This one's going to be x. This side's going to be negative 1, but we got to flip the inequality. So instead of being a less than, it's going to be a greater than. And let me write this one down on a piece of paper, just so I have it. Because I may, like I said, I think I'm going to graph this one on the graphing calculator. I mean, I could probably do it again really quick, but... All right, I think I got it. All right, so that's 3 of them. So we got 5 more to go. Is everybody good on that one? Again, because I'm going to erase. So again, we had to change the domain because really, if you think about it, if you flip the graph over the y-axis, that's kind of a horizontal transformation. All right, let's go on then. So I'm going to erase this one. So we got 5 more to go. Okay, so the next one I've got g of x equals negative of f of x. Well, if the negative was inside, it was a y-axis reflection. So what do you think this one is? This is the negative on the outside, right, out in front. Come on, be brave. If the last one was a y-axis reflection, what's this one? Yeah. Yeah, it's an x-axis reflection. So this one should be an x-axis reflection. So that's your transformation. And so now, if you think of that, if you're going to flip the graph over the x-axis, that's really not going to change the domains, okay? These are going to stay the same. It's still going to be one graph to the right of 1, and it's going to be the other graph to the left of 1. So those are not going to change on this one. So this is more of a vertical. By flipping it over the x-axis, it's more of a vertical transformation. So all we got to do for this one is just put a negative out in front of each branch or each piece. So that's going to look like, so we're going to have the 2 branches. We're going to put a negative out in front, and it's going to distribute on that top piece. And then we're going to put a negative out in front of the bottom piece also. Like that. And again, these domains are not going to change. So there we go. So now we simplify that. So that if we distribute this negative, right? Like that. So we're going to get a negative 2x plus 3, where the x's are, or if the x's are greater than or equal to 1. And then a negative of a negative x, that's just positive x. And that's if the x's are less than 1. And there you go. That was our 4th one. So we got 4 to go, and we're done. And you have a pretty short assignment today, too. Has everybody got that one? Anybody still writing? Okay, so I'm going to erase that one. So our next one is going to be, let me erase this first. Our next one is going to be f of 1/2 x. So that's going to look like f of 1/2 x. Then I'll erase this stuff. Well, again, it's inside. Do you guys see that? It's in the parentheses. So when it's in the parentheses, that means, again, I'm going to draw this and erase it afterwards. That means you're going to have to take the 1/2 x, and you're going to have to plug it in for that x, and for that x, and for that x, and for that x. You're going to replace all the, when it's in the parentheses, you're going to replace all the x's with whatever it says in the parentheses. So let me get all those arrows out of our way. And then, by the way, does anybody remember what this transformation is? It's a 1/2 on the x. First of all, is that horizontal or vertical? It's either going to be it's either going to be a vertical stretch, a vertical compression, a horizontal stretch, or a horizontal compression.
Horizontal stretch?
Yes, that's it. Yep. When it's a fraction between 0 and 1, it's actually a horizontal stretch. So the transformation, if I write it down here, this is a horizontal stretch by a factor that's the reciprocal of that number that's multiplied times x. That's when it's a fraction, okay? A fraction between 0 and 1. So it's actually a horizontal stretch by a factor of 2. Well, that means we're going to take our original graph here and we're going to stretch it out horizontally so that it takes twice the x value to get the same y value that you had on this original function. So again, we're just going to replace all the x's with 1/2 x though, so let's do that. So this one's going to look like, we got 2, and then we got to replace that x with 1/2 x. Oh, gotcha. Hopefully we catch it quick enough. Not this time, darn it. All right, give me a second here. There we go. Okay, so we replaced that x in the first piece by 1/2 x. But then again, because it's inside the parentheses, we also have to plug in 1/2 x wherever x is in the domain. And then on the bottom one again, we're going to plug in 1/2 x for the x. That's for the bottom piece. But we're also going to do that, replace that x in the domain for the bottom branch with 1/2 x. And then we just got to simplify this stuff. All right. So let's do that. So this is going to equal. So 2 times 1/2 is just 1. So this top branch is just going to become x minus 3. But then for its domain, you have to solve for x. So you're going to multiply both sides by 2 here. And then these 2's are going to cancel. All right, so that domain is just going to become x is greater than or equal to 2. And then the bottom branch, it's just negative 1/2 x. And same thing, we're gonna multiply both sides by 2 right here. So if we do that, we just get x is less than 2. There you go, that's that one. All right, so that was the, what? That was the 5th one, right? So we got 3 to go. Anybody got any questions on that one? All right. So I'm going to erase this one. So the next one we're going to do is, I'll erase this part first, I guess. The next one we're going to do is we're going to do 2 times f of x. So this is going to be 2 times f of x. So let me erase all this stuff now. You know, I suppose I could have been leaving those brackets there, or those, left that there for each time. Okay, so for this one, if you do a 2 out in front, 2 times the function, does anybody remember what that is? Is that a horizontal stretch, horizontal compression, vertical stretch, or vertical compression?
Vertical stretch?
Yep, if it's a number out in front greater than 1, it's a vertical stretch. So this is a vertical stretch. And what it does is it just makes the y values twice as large. So it just gets steeper or taller. So it's a vertical stretch by a factor of 2. So then all I have to do for this one is just, it's 2 times the function. It's on the outside. So it's going to be 2 times the top piece, like that. And it's going to be 2 times the bottom piece, like that. But again, this is a vertical transformation. So if you were to just take that original function, this one up here, and just stretch it vertically, if you just stretched it up and down, well then these values right here are not going to change. It's still going to be one graph to the right of 1, and it's going to be the other graph to the left of 1. So again, when it's a vertical transformation, when the transformation is not inside the parentheses, then you do not have to change these domains. So this part is still just going to say x is greater than or equal to 1, and this is going to say x is less than 1. So then we just simplify this. Well, all we got to do to simplify this, right, is we just got to distribute right here. And then we'll be done with this one. So if we distribute that, we got 2 times 2x, that's 4x. And then 2 times the negative 3 is negative 6. And that's where, or if x is greater than or equal to 1. And then the bottom one is just 2 times negative x, which is negative 2x. And that's where x is less than 1. And then that one's done. So then we got 6 of them done. We only got 2 more to go. Any questions on this one, or anybody need more time? Now the book, I really like, I mean, this is, I could have done this, I could have crammed this all into one day probably, but I like taking the time to show you like each, like I'm showing you every single type of transformation that you can have on the piecewise function, okay? Because the book, they give a couple examples and they do like maybe, 3 of them, like a x-axis reflection and maybe a shift 2 to the right and maybe a vertical stretch or something like that. That's it. And then they kind of want you to be able to, from that infer everything else that's going on. And I don't think that's very easy to do. So by showing you each one, I think you guys are starting to see the pattern that it's really not that bad. So let me erase this part. So the next one we're going to do is we're going to do f of 3x. All right, so let me erase all this stuff. Now let's see if you guys are catching on. I said hopefully you were going to start to infer what was going on. So on this one, you guys, is this going to affect the domains, yes or no? What's that? If it's inside, yes. Yeah, it is. Abby, did I call you Abby or Abigail? What's that? Okay. Abby, that's good. All right, you got it. Okay, if it's inside the parentheses, then it does affect the domains because this is going to be a horizontal transformation. In fact, again, what you're going to do is you are going to take the 3x, since it's in the parentheses, and you're going to replace all these x's over here with the 3x. Okay, everywhere there's an x over there, you're going to replace it with a 3x. Now, does anybody remember what this kind of transformation was called, this one? I guess I want to do that because I got to undo all these. So what is that one right there? Is that a vertical stretch, horizontal stretch, vertical compression, or horizontal compression?
Horizontal compression?
Yep, you got some good notes. That's good. Yeah, when it's a number greater than 1, and when it's inside, when it's multiplied times the x, that's your horizontal compression. So this one is a horizontal compression, which means you're going to take the graph and you are going to squish it horizontally. And the factor here is by a factor of, well, remember the horizontal ones? It's by a factor that's the reciprocal of that number. So the reciprocal of 3 is going to be 1/3. What does that mean? Well, that means it's going to take 1/3 of the x value to I guess, 1/3 of the x value will result in the same y value as the original function. Now remember, if you got a line and you squish it horizontally, it's actually going to get steeper, right? So think of a line with a slope of 2 there, and when you compress it horizontally, that line's actually going to get steeper. So let's see what happens. All right, so we got to put 3x in everywhere, right? So let's do it. So we're going to, this top branch or top piece is going to be 2 times 3x minus 3. And we got to remember to put that into the domain also. That's going to be where 3x is greater than or equal to 1. And then the bottom branch is going to be the negative of 3x. And that's going to be if 3x is less than 1. And then we just got to simplify that. So if we simplify that, the top branch, 2 times 3x, that's going to be 6x minus 3. But then we got to remember to solve these domains for x. So in this case, you got to divide both sides by 3. So if we do that, then this domain on the top piece is going to become x is greater than or equal to 1/3. And then the bottom branch is just the negative of 3x, which is negative 3x. And that's going to be where x is less than 1/3. So hopefully if you kind of caught on, we're going to do some stuff tomorrow where hopefully this stuff will start to sink in a little bit. Because I said when you compress this graph horizontally, it should get steeper, right? If you think about it, you got a line here to the right of x equals 1. X equals 1 is your boundary between these two pieces. Well, you got a line here to the right of x equals 1, and it's got a slope of 2. Well, if you took that line and you squished it horizontally, it would get steeper, and you can see now you got a line down here with a slope of 6, right? So this slope was up 2 over 1, this slope is now up 6 over 1, so yeah, it got steeper. All right, so we only got one more to go. You guys good? All right, last one. So the last one we're going to do 1/3 f of x. So 1/3 times f of x. And then I'll erase all this stuff. Okay, so then it's a 1/3 out in front. So does it affect these domains? Oops, I didn't want to erase those. Does it affect these domains then? No, because it's not in the parentheses, right? The 1/3 is out in front. So then so this is going to be a vertical transformation then. Vertical transformations do not affect the domain, so these are going to remain the same. So then by the way, again, what kind of transformation is this? A 1/3 out in front.
Vertical compression.
Yep, that's a vertical compression. So this is a vertical compression by a factor of 1/3. Well, that just makes that's going to make the graph flatter or less tall if you squish it vertically. All right, so all we got to do on this one then is we got to just put a 1/3 out in front of the function. So we're going to put a 1/3 out in front of this top piece, so 1/3 times 2x minus 3 in parentheses. We said that these domains were not going to change. And then we got to put a 1/3 out in front of this bottom piece. And that domain's not going to change either. Okay, so again, any vertical transformations, the domains do not change. Well, now on the top there, just go ahead and distribute that 1/3. So you're going to get 2 times 1, or 1/3 times, oh, thanks. So you're going to get 1/3 times 2x. So that's just 2/3 x. So we're going to get 2/3 x and then minus 1. Domain stays the same. On the bottom, it's just 1/3 times negative x, so that's a negative 1/3 x. And the domain stays the same. And that's it. That's all we got. So that was kind of tedious, but hopefully it kind of sunk in a little bit on what's going on. All right, and then your assignment is already up on the board over here, but I'll write it down here so you guys can see it. So the assignment for this, this is again section 9-3. This is on page 676. And all you got is 5 problems. So you got 1, 2, 8, 9, 10. And there's another half to this lesson tomorrow. I don't know. I just felt like it would be really, really long if I did it all in one day. So we're going to split it up. And plus, if you kind of get the hang of this, it'll kind of make, like tomorrow's lesson will make more sense. Now I want to give you a couple hints on the homework. So let me turn to the page where the homework is. What they do in the homework is they don't write down this rule right here for you. They write it down in words like this. So they tell you the transformation is going to be a vertical compression by a factor of 1/3. And then you're supposed to write this part to figure out what to do to the piecewise function. So I'm going to help you with that part. Okay? So let me go to chapter 9 here. And let me find this 9.3 stuff. Did I go too far? That's 9.2. There we go. So let's look at the homework. Okay, so we got to do 1 and 2, right? So let me zoom in on this for you guys. See if I can fit all these on the screen at the same time. So I got 1, 2, 8, 9, and 10 on there all at once. So the first one, it says, it says g of x is a horizontal translation of f of x 6 units to the left. Okay? So if it's going to be 6 units to the, here, let me zoom in on this even more so you guys can see. So it's going to be, so here's f of x right here. And we're going to go 6 units left. So if we want to go 6 units left, the rule for that is actually going to be, we're going to want to go f of x plus 6. Okay? And that means it's in the parentheses, it's inside, so that means you got to plug it in for every x, okay? You're going to plug it in, you're going to plug x plus 6 in here, and in the domains. And then simplify. Now the next one, number 2, that one's a horizontal compression by a factor of 1/4. So you got to remember when you do a horizontal compression, that's inside, okay? That number is multiplied times the x. But on the compression, or the horizontal ones, I mean, the horizontal stretches and compressions, you also got to remember to take the reciprocal of this number right here, right? So that one is going to be, that's going to be f of 4x. Okay, so again, it's inside because it's horizontal. It's in the parentheses, but it's got to be the reciprocal of that number. So since it's inside the parentheses, and then you're going to put a 4x in for this x and that x and the x's in the domain. And then simplify. And then let's look at 8, 9, and 10. So 8, 9, and 10. Number 8, that one says you got to do a vertical compression by a factor of 1/4. So it's a vertical compression. So on this one, it's going to be on the outside if it's a vertical stretch or compression. And you do not do the reciprocal. So this one is actually just going to be, they're using f of x again here. So this one is just going to be 1/4 f of x. Or 1/4 times f of x, like that. So now that is a vertical transformation. So on that one, then you don't have to mess with these domains. They're going to stay the same. Okay? And then number 9, we need h of x is going to be a horizontal stretch by a factor of 2. So if it's horizontal, again, it's going to be inside. It's going to be multiplied times the x, but again, since it's a horizontal stretch or compression, you got to take the reciprocal of that number. So this one should be, number 9 should be f of 1/2 x. And then, since it's inside the parentheses, then you're going to have to put the 1/2 x in here for that x. Also for that piece right there, you got to plug in 1/2 x. And in the domains, you got to plug in 1/2 x for those x's. And then number 10, the last one, p of x is a vertical translation of f of x 3 units down. So 3 units down, that is just going to be f of x minus 3. So the 3 is going to be on the outside. So that's just going to move it down 3 units. That's going to subtract 3 from all the y values on that graph. So again, this one is a vertical transformation. So again, on this one right here, number 10, then you do not have to mess with these domains, okay? They're going to stay the same. All right? I think that's all the hints you're going to need there. So the only two that you don't mess with the domains on, or that you don't have to change the domains, is it's number 8 and number 10. And then